Yeah, we can see it.
Okay, great. So I'm going to be presenting on the water level data products collected by AirSWOT. So AirSWOT collected a record number of flight lines for Delta X during the spring and fall campaigns over 21 science flights. And there's a few different processing levels that you can download, different AirSWOT data products. I have them linked here. So I'm going to talk about the level 2 and the level 3 products in this presentation. The level 1B products, if you're interested in those, you're welcome to contact me if you have any questions, but I think those are a lower level data product, so I expect that most users will want to use the level 2 or the level 3 products, which are both GIS ready. The level 2 water surface elevation product is in GeoTIFF format, so they're raster files, and the level 3 water surface elevation product is point data, and it's a comma separated values text file. And you can see here, this is the aircraft that AirSWOT flew on during Delta X, and this is a picture of the radar instrument panel that collected the data. I'm not going to really talk about the radar during this presentation, just the data products, but it uses interferometry to measure the surface elevation of open water areas. So as Talib showed in the previous presentation, UAVSAR gives you water surface elevation change in the wetlands, and AirSWOT gives you water surface elevation in the open water. So first I want to talk about the level 2 data product. So these are geocoded GeoTIFF raster files. They're in the UTM coordinate system. And so they give you the water surface elevation with a uniform 3.6 meter pixel spacing. And we give you two files. There's one where the water surface elevation is with respect to the WGS 84 ellipsoid. And there's another file where it's with respect to NAVD 88, which I'm guessing probably most users will wish to use. And on the right here, you can see an example of what that level 2 data product looks like. So this is for the Atchafalaya. I'll show an example in the Terrebonne in a couple slides. But so you can see here, each pixel is colored according to the water surface elevation. And this data product compared to the level 3 data product has the highest fidelity compared to the radar imagery that's actually collected by AirSWOT. So it's at a higher resolution, that 3.6 meter pixel spacing. But as you can see here, it is a bit noisy in some places. And I see Young just linked the download for this data product, so thank you. So you can see it is a bit noisy in some places. So for the level 3 data product, we do some averaging to reduce the noise. So it's just something to keep in mind, that the level 2 data product is very high resolution, but is also noisier than the level 3 data product. It also includes land pixels. It's not just water, as you can see here. It's really just the elevation of every pixel that was observed by AirSWOT. So for land pixels or for vegetated pixels, it will be the height of the vegetation or the land. So it's not just the water at this processing level. But if I move to the level 3 product, you can see that now we only have points rather than a raster, and they're only in the water. So to create the level 3 product for AirSWOT, we actually use the UAVSAR water mask data that Talib showed in the previous presentation. So we use some of the other Delta X data products to mask out the land areas, which leaves us with something like this. So if I go back really quick, this is the level 2 data product, and then these data products are used to create this, which is just a masked and spatially averaged version of the water surface elevation. So as you can see, some places are missing points. That's because there's certain parts of the data where we don't get a good signal, so we try to remove those. And each node doesn't just represent one pixel now, it represents kind of an area around that pixel. In addition to that, we also add some extra attributes to these files that identify if a node is in some of the major channels in the area and its distance along that channel. And the idea of doing that is that it makes it easier to plot water surface elevation profiles and calculate the slope in these channels, which I'll talk about in a moment. So here are just a couple examples of AirSWOT Level 2 data products. So this is another Atchafalaya flight. And then this flight was in the Terrebonne. So I just wanted to show an example of what the data products look like in both of the different basins that Delta X collected data in. And then if I go ahead again, now you can see the level 3 data products for these two flights. I should say these nodes are colored according to the height of the last time that area was collected during the flight, which are at different times. So that's why some of these nodes have different water surface elevations. The slopes in the Terrebonne aren't this significant. This is because some of these flight lines were collected at different times than other flight lines. So it's really more of a change in water level over time. This isn't like a slope, if that makes sense. And just to show an example of what you can do with the level 3 data products. So this is for the Wax Lake outlet, which is one of the channels that's identified in the level 3 product. And so if you open the level 3 data file and you look at all of the nodes that are labeled with the Wax Lake outlet WLO in the file for the channel ID, and you plot those nodes against the along channel distance, which is also in the file, you can create profiles like this. And I've added this dashed line as just a smooth version from these points, but these blue dots are what's actually in the file. These are the nodes measured by AirSWOT. And the black marker here is the USGS Calumet water levels, which I added just as reference. And if you take this profile with this smooth version that I fitted, you can also calculate the slope along the profile. And here we see that the slope starts pretty steep at the beginning of the profile and gradually decreases in slope as we move kind of closer towards the ocean. And I just wanted to show an example that AirSWOT gives you the slope at different times. So every flight and multiple times per flight, AirSWOT collected data over the Wax Lake outlet, and this animation is just looping through. This is the USGS Calumet time series, and as we move through the time series, these are the different dates and times that AirSWOT collected data. And on the left, you can see that's the profile in the AirSWOT level 3 data products for each time. So you can see that depending on the time, there's a lot of different slopes in the data. Sometimes the channel was steeper, sometimes the channel was less steep. Sometimes we don't get a slope in the full length of the channel. That depends on the conditions on that particular day, because as I mentioned, some of the data, if it wasn't as good quality, we leave it out, and that depends on the roughness of the water surface on that day, which is usually a function of wind. So if the water was too smooth, we don't get good signal from the water, and we can't collect data. But most of the time, you get most of the channel. And just kind of moving quickly, but some of the other channels that are in the level 3 data is the Atchafalaya River, which you can see here. And this is just an example profile from that river. And we also have the Intracoastal Waterway in the Atchafalaya as well. This is just an example profile of the Intracoastal Waterway. So just to wrap up, so AirSWOT, collected more data for Delta X than any previous AirSWOT campaign. And Young linked download in the chat. You can also find them if you go onto the ORNL DAC and search for AirSWOT or AirSWOT Delta X. So we've released version 2 of the level 2 and level 3 products, which had some calibration improvements compared to the first version. And as I've shown, so the level 2 and level 3 products can both be useful, but it depends on your application, I would say. The level 3 products are probably the most science-ready processing level if you just want something that's easiest to use. The level 2 products require a little more processing. You probably want to use a water mask and do some noise filtering or spatial averaging. And the great thing about AirSWOT is that you can map water surface elevation in space, which can give you the water surface slope, which you can't do very easily, at least not at that kind of spatial resolution using the in situ data. So that's kind of what AirSWOT adds. And last, I'll just say if you are interested in AirSWOT data and you have any questions or comments, please contact me. My email is there. I think it's also on the download pages for the AirSWOT data. So thank you. That's all I have.